Okay, we have the derivative of trigonometric functions. Now, in our derivative of trigonometric functions, these are the different formula to solve the derivative of trigonometric functions. We have the derivative of sine u equals cosine u du, and also the derivative of tangent u equals secant squared u du, and then the derivative of secant u equals secant u tangent u du. In addition to that, we also have the derivative of cosine u equals the negative sine u du. Now, actually, this sine u and cosine u are partners. If we have here the derivative of sine u equals cosine u du, then the derivative of cosine u equals the negative sine u du. Also, for tangent u and cotangent u, if the derivative of tangent u equals secant squared u du, then the derivative of cotangent u equals negative cosecant squared u du. And also, the derivative of secant u equals secant u tangent u du, and the derivative cosecant u equals negative cosecant u cotangent u du. In other words, the derivative that starts with letter C for trigonometric functions are negative. So take note of this derivative of our trigonometric function. Now this time, we will start by having an example. Okay, so we have, let's say, example 1. Okay, in our example 1, let's say, y, we have here a function y equals sine 2x. Okay, now take note, sine 2x, this is our formula. We will be using this formula. Applying this formula, the derivative of sine u equals cosine u du. For this case, y equals sine 2x. This 2x will serve as our u. Okay, so we take the derivative, that is y prime, which is then equivalent to the derivative of sine u equals cosine u du. So the derivative of sine 2x equals cosine 2x times the derivative of, okay, the derivative of 2x. This is how we take the derivative of sine 2x, so that you will have, or this is equivalent to cosine 2x times the derivative of 2x, that is equivalent to 2. Now take note, do not multiply 2 by 2x because 2x here is the angle of your cosine. Okay, so I will just rewrite this cosine. Okay, so rewriting this one, we have here cos of 2x. So our final answer is, we will just transfer this 2 before cosine 2x. So we have here 2 cosine of 2x. That will be our derivative of your function y equals sine 2x. Okay. Another example, we have, let's say, y, another function, y is equivalent to, let's say, tangent, tangent of square root of 4 plus 3x. Okay, now this one is tangent u. This will serve as our u. Y equals tangent u. So derivative of tangent u equals secant squared u times the derivative of u. Okay, so we have here y prime, that is equivalent to, so we take the first derivative, derivative of tangent u, derivative of tangent u equals secant squared u du. So that is secant squared of your u, which is 4 plus 3x raised to 1/2 times the derivative of, okay, derivative of our u here is 4 plus 3x raised to 1/2. 4 plus 3x raised to 1/2. Okay, so that we have the derivative of y prime, because again we will write this one. So we have secant squared of the square root of 4 plus 3x, and then the derivative of 4 plus 3x raised to 1 half. This is derivative of u to the n, following the formula of derivative of u to the n. We have our formula, derivative of u to the n, that is nu n minus 1 du. That is power rule. So you have here your exponent as your n. This is 1 half. Okay, so we will just follow this rule. Our derivative of u to the n equals n. So for this case, derivative of 4 plus 3x raised to 1 half equals 1 half. Okay, so we have 1 half 4 plus 3x. And then 1 half minus, that is n minus 1. 1 half minus 1, that is negative 1 half. Times the derivative of our u, times the derivative of our u equals 4 plus 3x. 4 plus 3x. Okay. Therefore, this one, we will now write our answer here. So we have number 2, that is equivalent to, okay, that is secant squared square root of 4 plus 3x. Square root of 4 plus 3x. And then allow me to transfer this one first. Okay. So, secant squared of square root of 4 plus 3x. And then we have here the exponent is negative 1 half. So, that is equivalent to our 1 half here is 1 over. This is our 1 half, 1 over 2. And then instead of negative 1 half, our exponent here, we make it positive. So make this one as your denominator. So you have here your square root of 4 plus 3x. And then the derivative of 4 plus 3x equals 3. So we have here 3. So that our final answer will be y prime, that is equivalent to 3 times 1, that is 3 over 2. So I will write here 3 multiply 3 times 1 equals 3 times secant squared. So I have secant squared is square root of 4 plus 3x divided by, okay, 2 is square root of 4 plus 3x. You have here 2 is square root of 4 plus 3x. Okay, that is how we take the derivative of this function, tangent is square root of 4 plus 3x. Okay, so another example. So we will have another example for the derivative of trigonometric function. So let's say number 3, another example. We have y is equivalent to 2x cubed cotangent, let's say 4x. If you have noticed, we have here 2x cubed and we also have cotangent of 4x. So this is an algebraic function, and then this is a trigonometric function. So this is a combination of two functions. Therefore, when we apply the derivative here, so we make use of the formula, the derivative of uv, which is equivalent to u dv plus v du. So we will make use of this formula to apply for this particular problem. Therefore, when we take the derivative, okay, so that is y prime, which is equivalent to, this will be our u, this will be our v. So u, that is 2x cubed times the derivative of your v, derivative of cotangent 4x, okay, that is u dv, plus v du. This will be our v, cotangent 4x v du times the derivative of our u equals 2x cubed. Okay, so that is now equals to 2x cubed for this case, 2x cubed, derivative of cotangent 4x, that is derivative of cotangent u, equals negative cosecant squared u du. So we will copy that formula, negative cosecant squared u. Our u here is 4x. Okay, that is negative cosecant squared 4x times the derivative of our u, which is 4x. This is now du. Okay, plus this one, cotangent 4x. I will write cotangent 4x. And then the derivative of 2x cubed, that is 6x squared. So I will write here 6x squared. Okay, 6x squared is the derivative of 2x cubed. So that when we have here the derivative of 4x, that is 4 times negative, so negative 4 times 2, that is negative 8. So negative 8x cubed, and then we have here cosecant squared of 4x. This is now the result of the derivative of this part. Take note, 2x cubed times negative, that is 2, negative 2x cubed. And then the derivative of 4x equals 4. So 4 times negative times 2, that is negative 8x cubed cosecant squared 4x. And then plus this one, we will do not multiply 4x by 6x squared. Instead, you have to write first 6x squared before cotangent 4x. So we have here plus 6x squared cotangent of 4x. That will be our final answer for this problem. Okay, example 3. So that is the derivative of trigonometric function, or that is how we use all this formula. Okay, so that is trigonometric function. Another example, we will have here another example. Okay, so additional example, let's say number 4. So number 4, let's say y is equivalent to sine of sine 3x. Okay, so this will be our u, sine u. Okay, sine u. When we take the derivative of sine u, take note the derivative of sine u, we have here derivative of sine u equals cosine u du. So take note of that formula. So we have derivative of sine u equals cosine u du. So take note, this will be our u. So the derivative, we have here y prime equals derivative of sine u equals cosine of u, that is sine 3x, cosine u times the derivative of your u, which is sine 3x. So that this is equivalent to cosine of sine 3x, derivative of sine 3x, again this is derivative of sine u, that is cosine u. So we have here cosine of 3x times the derivative of 3x. Okay, derivative of 3x equals 3, so that we will write 3 first here. Derivative of 3x equals 3, and then we will write here cosine 3x, cosine 3x, and then we will write this one, that is cosine of sine 3x. Okay, so I will write here the parenthesis. Okay, so we have here a combination of 3 cosine 3x and cosine of sine 3x. Take note, your angle for cosine here is sine 3x. Okay, example number 5. Let's say y is equivalent to ln of mm, tangent, let's say 6x. ln of tangent 6x. Okay, so when we take the derivative of this one, we have derivative of ln u. Take note, the derivative of ln u equals 1 over u du. That is our formula that is applicable for this equation. So we have y prime. This is ln of u. This will be our u. So the derivative of ln u equals 1 over u. 1 over tangent 6x times the derivative of tangent 6x. Tangent 6x. Okay. So 1 over u derivative of u. That is our formula for the derivative of ln u. And so we have 1 over tangent, that is the inverse of cotangent. So we have 1 over tangent 6x equals cotangent 6x. And then the derivative of tangent 6x, that is secant squared x. I mean derivative of tangent u equals secant squared u du. So take note, the derivative of tangent u equals secant squared of 6x times the derivative of 6x. So that our final answer here equals y prime equivalent to cotangent 6x and then secant squared 6x. Derivative of 6x equals 6. I will write here 6. Okay, I will transfer 6 instead of writing 6 on this part, so I will transfer it here. So 6 cotangent 6x. Now, cotangent, take note in a trigonometric function, cotangent, I will write here, cotangent u equals cosine u over sine u. And then secant squared 6x or secant squared u, secant squared u is equivalent to 1 over cosine u. 1 over secant is 1 over cosine squared u, because this is squared, so secant equals 1 over cosine. So we will write this one 6. Instead of cotangent 6x, we will write cosine of 6x, cosine 6x over sine 6x. And then secant is 1 over cosine 1 over cosine squared 6x. So we can cancel cosine 6x and 1 of this squared. So equivalent to 6 times 1, that is 6. Okay. Times 1. Okay, I will just write it in this manner. Okay. And then we have here 6. 1 over sine 6x, and then this one 1 over cosine 6x, and that is equivalent to 6. 1 over sine 6x, that is equivalent to cosine cosecant 6x, and 1 over cosine is sine 6x. So we have here sine 6x. So sine cosecant, this will be our final answer. Or you can make use of your half angle formula for this one. Okay, so we can make use of this one as our final answer, or your half angle formula for sine x cosine x. Take note, sine x of cosine x equals 1 over sine 2x. I mean, that is an half angle formula. Okay, so if we retain this one, that is equivalent to 6. I will write 6 times 1 times 1, that is 6, divided by, I will combine here, you have here sine 6x cosine 6x. Now again, take note, we have, let's say, sine 2x that is equivalent to. So the equivalent of sine 2x that is equivalent to 2 sine x cosine x. So for this case, this is sine 6x cosine 6x. This can be rewrite as 6 divided by, okay, this case, you will transfer 2 to the other side. So we have, this is double, actually this is double angle formula. We have sine, this is 2x. If this is x, then you have here 2x. So for this case, if this is 6x, then you will have 12x divided by 2. We have here 2 over 2. So 2 will be transferred here. So 2 times 6, that is 12. That is 12 over sine 12x. But 1 over sine 12x, okay, sine 12x, okay, I will erase this one first. I will rewrite it. Okay, we have here sine of 12x. Okay, 12x, so 1 over sine equals cosine 12x. So we can have our final answer as 12, 1 over sine is cosecant of 12x. So we can have this one as our final answer, or we can make use of this one, okay, but this one is most preferable answer for this particular problem.